What is confusion matrix? A confusion matrix, also known as an error matrix, is a table that allows the visualization of performance of a classification model. It is widely used in machine learning and statistics to evaluate the performance of a classification algorithm by comparing the predicted class labels with the actual class labels of a data set. A confusion matrix is typically represented as a square matrix where the rows correspond to the actual classes and the columns correspond to the predicted class. The diagonal elements of the matrix represent the correct predictions, true positive and true negatives, while the off-diagonal elements represent the incorrect predictions, false positives and false negatives. So this is a confusion matrix. Predicted positive, predicted negative. Then in first column we see actual positive and actual negative. These are values: true positive, false negative, false positive, true negative. The confusion matrix consists of four cells: true positive, true negative, false positive, false negative. The confusion matrix provides valuable information about the performance of a classification model. From the matrix, various evaluation metrics can be derived, such as accuracy, precision, recall, F1 score, which help assess the model's predictive power, sensitivity, specificity, and overall performance. By examining the confusion matrix, one can gain insights into the types of errors made by the model, identify any class imbalance or biases in predictions, and make informed decisions about model's strengths and weaknesses. It is especially useful when dealing with imbalanced datasets or when different types of errors have different consequences in the application domain. These are the basic measures derived from confusion matrix. Precision: true positive by true positive plus false positive, true positive by true positive plus false negative. F1 is 2 into true positive by true positive plus false positive plus false negative. These are the some basic measures. What is the difference between long and wide format data? The term long and wide refers to the different formats in which data can be organized or structured. These formats are commonly used in statistical analysis and data manipulation tasks. Here is the difference between the two. Long format data, also known as tidy or normalized format, each row represents a unique observation or data point. Variables are typically stored in separate columns. Additional columns may be used to represent attributes or characteristics of the observation. It is often the preferred format for statistical analysis and modeling. Long format data is more flexible and allows for the easier data aggregation and manipulation, suitable for situations where the focus is on individual observations and their attributes. Wide format data, also known as unnormalized or pivot format. Each row represents a group or category of observations. Variables are usually stored in a single row with separate columns for each variable. The format is more compact and may be easier to read for simple datasets. It is commonly used for data presentation or summary purposes. Wide format data can be useful when dealing with categorical or hierarchical data, suitable for situations where the focus is on summarizing or presenting data for a group or category. To illustrate the difference, let's consider an example with student test score. This is student ID, subject score. Student ID 1, 1, 1, 2, 2, 2. And student subject math, English. This is long format. And then wide format is this: student ID 1, 2, math 80, 90, English 75, 70, 85. This is the difference between long format and wide format. Each row represents a unique student subject combination with corresponding score. This format is suitable when analyzing individual student performance or conducting subject-specific analysis. In the wider format, each row represents a student and the score for different subjects are organized in separate columns. This format is more suitable when comparing overall performance between students or presenting a summary view of the data. Wide format is used. The choice between long and wide format depending on the specific analysis or task at the hand. It is important to select the format that best suits the objective of analysis and facilitates the desired data manipulation and interpretation. What do you understand by the term normal distribution? The term normal distribution, also known as Gaussian distribution or bell curve, refers to a continuous probability distribution that is symmetric around its mean. It is a fundamental concept in statistics and probability theory. The normal distribution is characterized by following properties. First property, shape. The distribution has a symmetric bell-shaped curve with the highest point at the mean. The curve is unimodal, meaning it has a single peak. Second, mean and median. The mean, median and mode of a normal distribution are equal and located at the center of the distribution. Third, standard deviation. The spread of the distribution is determined by standard deviation. The curve is more concentrated when standard deviation is smaller and more spread out when the standard deviation is larger. The normal distribution follow empirical rule. Number 4, empirical rule. Also known as the 68, 95, 99.7 rule, which states that approximately 68% of data falls within one standard deviation of the mean, about 95% falls within two standard deviations, and approximately 99.7% falls within three standard deviations. Number 5, Z-score. The Z-score, also called the standard score, is used to standardize values from a normal distribution. It represents the number of standard deviations a particular value is away from the mean. Number 6, parameters. The normal distribution is fully described by two parameters, the mean and the standard deviation. These parameters determine the location and spread of distribution respectively. The normal distribution is widely used in various fields of study and real-world applications. Many natural phenomena and measurement errors tend to follow a normal distribution. It serves as a fundamental assumption in many statistical techniques and provides a basic basis for hypothesis testing, confidence intervals, and other statistical inference methods. Additionally, the central limit theorem states that the sum or average of a large number of independent and identically distributed random variables tend to follow a normal distribution regardless of underlying distribution of variables themselves. Random variables are distributed in the form of symmetrical bell-shaped curve. Properties of normal distribution are as follows. Number 1, unimodal, only one mode. Number 2, symmetrical, left and right halves are mirror images. Number 3, bell-shaped, maximum height mode at the mean. Number 4, mean, mode and median are all located in the center. Number 5, asymptotic. Question number 7. What is correlation and covariance in statistics? Correlation and covariance are statistical measures that describe the relationship between the variables. While they are related concepts, they differ in their interpretation and scale of measurement. Number 1, correlation. Correlation measures the strength and direction of linear relationship between two variables. It quantifies how closely the values of variables move together. Correlation values range from -1 to 1. A correlation coefficient of +1 indicates a perfect positive correlation, -1 indicates a perfect negative correlation, and 0 indicates no correlation. Correlation is dimensionless, meaning it does not have units of measurement. Correlation measures the degree to which variables change together, but it does not imply causation. covariance. Covariance measures how changes in one variable are related to changes in another variable. It captures the directional relationship between the variables. Covariance values can be positive, negative, or zero. A positive covariance indicates a positive relationship. Negative covariance indicates a negative relation, and zero covariance indicates no relation. Covariance values are influenced by scale of measurement of variables. Therefore, it is challenging to interpret the magnitude of covariance. Covariance is affected by units of measurement of the variables. Consequently, comparing covariance values across different datasets or variables is not meaningful. In summary, correlation provides a standardized measure of the linear relationship between variables ranging from -1 to 1. It is suitable for comparing the strength and direction of relationship between variables. On the other hand, covariance measures the overall directional relationship between variables but is influenced by units of measurement. Question number 8. What is the difference between point matches and confidence interval? What is the difference between point estimates and confidence interval? Point estimate and confidence interval are both statistical concepts used to estimate population parameters based on sample data. However, they differ in terms of information they provide and the level of uncertainty associated with the estimate. Point estimate. A point estimate is a single value that is used to estimate an unknown population parameter. It is typically calculated using sample data and serves as an estimate of the true population parameter. Point estimates provide a single estimate of parameter without any indication of uncertainty associated with the estimate. Examples of point estimates include sample mean, sample proportion, or sample regression coefficient. Confidence interval. A confidence interval is a range of values within which the true population parameter is likely to fall with a certain level of confidence. Confidence intervals provide information about the precision and uncertainty of estimate by specifying both a point estimate and a margin of error. The confidence level represents the probability that the true parameter falls within interval. Commonly used confidence levels are 90%, 95%, and 99%. The wider the confidence interval, the greater the uncertainty associated with the estimate, while a narrower interval indicates higher precision. In summary, a point estimate provides a single value estimate of a population parameter, while a confidence interval provides a range of values within which parameter is likely to lie. Confidence intervals incorporate both the point estimate and the associated uncertainty, providing a more informative measure of estimate's reliability. What is the goal of A/B testing? It is a hypothesis testing for a randomized experiment with two variables A and B. The goal of A/B testing is to identify any changes to the web page to maximize or increase the outcome of interest. A/B testing is a fantastic method for figuring out the best online promotional and making marketing strategies for your business. It can be used to test everything from website copy to sales emails to search ads. An example of this could be identifying the click-through rate for a banner ad. The goal of A/B testing is to compare two or more variations of web page features or marketing campaign to determine which one perform better in terms of specific goals or key performance indicator. The specific goals of A/B testing may vary depending on the context and objective of experiment, but some of the common goals include conversion rate optimization. A/B testing is often used to improve conversion rate, such as increasing the number of users who make a purchase, sign up for a newsletter, or complete a desired action on a website. User experiment improvement. A/B testing can be employed to enhance user experience by comparing different designs, layouts, and navigation structure to determine which one provides a better user experience, usability, or engagement. Content optimization. A/B testing allows for testing different variations of content such as headlines, product descriptions, call to action buttons to identify the most effective messaging or content strategy. pricing strategy. A/B testing can be utilized to evaluate different pricing models, discount offers, or pricing strategy to determine which one lead to higher revenue or customer satisfaction. Ad campaign optimization. A/B testing can help optimize advertising campaigns by comparing different ad creatives, placements, targeting options, or messaging to identify the most effective combination for achieving campaign objectives. Overall, the goal of A/B testing is to gather empirical evidence and insights to inform decision making, optimize performance, and drive improvement in various aspects of a business or user experience. What is p-value? The p-value is a measure that quantifies the strength of evidence against the null hypothesis in a hypothesis test. It is used to determine the statistical significance of an observed effect or result. The p-value represents the probability of obtaining a test statistic as extreme as or more extreme than the observed value, assuming that the null hypothesis is true. In other words, it measures the likelihood of observing the data or a more extreme result if the null hypothesis is true. Typically, a p-value is compared to a predetermined significance label, often denoted as alpha, such as 0.05 or 0.01, to make a decision about the null hypothesis. If the p-value is less than the significance label, p is smaller than alpha, it is considered statistically significant, indicating strong evidence against the null hypothesis. In this case, the null hypothesis is rejected in favor of an alternative hypothesis. Conversely, if the p-value is greater than the significance label, p is greater than or equal to alpha, it is not statistically significant and the null hypothesis is not rejected. It is important to note that p-value is not a measure of size or practical significance of an effect. It only provides information about the strength of evidence against the null hypothesis based on observed data. The interpretation of p-value should be done in conjunction with other considerations such as effect size, study design, and practical implications.